NHT 2025 Exam 1, questions 25 to 34, matrices.
Okay, so this is a symmetric matrix, which will work out the values of A, B, and C. Well, remember, symmetric matrix, the first row is the same as the first column, so that one's got to be 7, because if it goes 0, 1, 7, 3, it goes 0, 1, 7, 3. If it goes on the second row is the same as the second column, so they've got to be 2 and 8. And there's your values. So 7, 2, 8. 7, 2, 8 is option A. Okay, so k times k to the minus 1 equals I. That's the basic equation. Often you might have seen it written in books like A times A to the minus 1 equals I. So anything times its inverse is I, the identity matrix. Answer D. Okay, we've got a Leslie matrix, and we've got a key phrase in here that says in the long term, which is why I've got power 50 here. And I've just taken this diagram and made it into this Leslie matrix here. And so it said in the long term, to power 50. Now, the recommended thing from the actual VCAR thing is just make up a starting matrix with some nice numbers. And so those numbers would actually be 400 for each of them. And after a long time, 50 cycles, you get roughly these numbers, which I've summarized here, and you end up with 335. So the population has decreased. So it's an interesting technique to learn, just to put in just some very simple starting point. It's kind of like an S0 there going on there, and see what happens to it. Is a sort of trick. You could have tried to do something fancy and not done the S0, but then you'd have horrible fractions and you have to really understand what's going on, and your brain would probably hurt. I think this is probably the easiest way to do it, which is actually the VCAR approved way. Okay, so we've got matrix B and C, and so C, how do you get that from B? Well, you can just check all of these things. As for example, 45 has become 60. So 60 divided by 45 is 4 over 3. And that would be true of any pair of elements you chose here. So the answer is D. It was as simple as that. It's just a simple scalar multiplication. Now what we want here is we've got this matrix product here that will give a total for L and F. So basically we know the answer we need. The answer we need is going to be 1 by 2, because it is a row matrix. So this is a 2 by 4. This is a 2 by 4. So C minus B is also a 2 by 4, but C minus B transpose is a 4 by 2. So when we put this x in for the C minus B transpose, we know it's going to be a 4 by 2. We know this is going to be a 4 in the X matrix, because it's going to match up with the 4 in the C minus B transpose. And it's a row matrix, so it's going to be 1 by 4. And then you can actually see that this is the 1 and the 2 that we wanted. So the only one that is a 1 by 4 matrix C. Answer C. Okay, quite a difficult question to unpack, and even the answers have gone a bit quick over the explanation. I've got this up here, they've got this P1 and P2. There are only 2 possible permutation matrices for multiplying this through. Now, it does say that question 1 and question 4 never change. That means they're on the leading diagonal 1 and 4. So these 2 positions are fixed, which also means that these zeros are fixed. Now, since the zeros are fixed, there's only 2 places, for example. This can only go here or here. It can't have a 1 in this column or this column, and it can't be in this row because it's 0. So it's only got those 2 spots here and here, you see? That's why it's oscillating between the 2. All right, I just pause and think about that. So that's why there's only 2 places that 1 could go. And that's the difference between P1 and P2. And if you follow through the logic, you'll see the same thing, that this 1 can either go here or here, and this one can go here or here. Those are the only possibilities that you've got there, the two positions for these things. They kind of gloss over how you do that, but it's just a bit of a logic puzzle. All right. So the leading diagonal is set by this 1 and 4 never change, whereas 2, 3, and 5 change. And the only way they can change is these two possible permutation matrices. Now it says like you go through both of them, but you don't actually have to. What you have to do though is keep changing the power here, because they've given you in the order that it is Q, P to the n minus 1. So, confusingly, since my n here is 3, that's n minus 1 equals 3, so n equals 4, and you can see when I did power 3, the letters did not change order, therefore the answer is C. You didn't actually have to test both ones. This is actually matrix P2, permutation matrix P2 I've done there. You'll find the same thing will happen with if you did matrix P1. You didn't have to test both of them. You only have to test one and find that thing, but you could get quite easily confused by going power 3, test 3. Pause and think about it. It's quite a bit to unpack there. Okay, we have students moving from L1 to L2 and then to graduating. We know this is 80% and this is 60%, while 0.8 times 0.6 is 0.48. Answer is B. All right, quite a bit going on here. We're going to work out the transition matrix, which is not so hard. This is your L1, L2, G, L1, L2, G, and we got those numbers from these numbers, got this the 0.8 and the 0.6, and we need a 1 here because graduating stay graduating, they don't go backwards, so we're talking about that. So no student leaves the course before graduating. That gives us that 1. Then I've got my T then, and I've got my S. If I do T times S, I get these numbers, and it tells us that we need to keep the L1s at 1,000. But you can see 1,000 went to 200. So if 1,000 goes to 200, how do I get it back up to 1,000? I add 800. So therefore my K value is 800. Then I'm just going to set up some sort of recursive calculation, because otherwise it's going to be a pain in the butt. I'm just going to talk a bit about how to do that on your calculator. So I'm just going to delete all this stuff. And so what I did was, if you do T times S plus B, you get this point. Then I type on my calculator T times ANS. This is your ANS here, because it's going to go over to here, plus B. And then the calculator reorders it to that. So if you type T times ANS, I just typed the letters ANS, probably the quickest way to do it on your calculator. And then I just kept tap, 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 tap. And when I tap, 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 I got to this point, and we need to know when it first gets past 5,000. Here we got past 5,000. That was my 8th tap. So the answer should be B, 2023, because 2025 plus 8 is 2023. There you go. Whew. A fair bit to unpack in that.